Today's lecture is on professional C++ coding standards. So different software development companies have different coding standards. So for example, if you go to IBM, they most likely will give you their coding standards, and if you go to Microsoft, they probably will give you different coding standards. So what we are going to cover today are some common conventions that most people follow. First, source code organization. So for files, so one file should contain the definition and or implementation of only one class. So, and also the name of the file should be equal to the name of the class. For example, you may have an employee class. You can put it in the employee.h file, and so you put the interface in the employee.h and put the implementation of the member functions in employee.cpp. And typically the .h file are designed by the architect, and the .cpp file are implemented by the programmers. So header files. So you should include the header files using this include, and in your include statement, you should avoid using absolute paths like this. What you should do is you should just include the name of the .h file. And now the question is where to specify the path of this .h file. Well, makefile is the right place to specify paths. And if you use NetBeans, typically that's already automatically taken care of by the IDE environment. And for each header file, you should use this if not define and define and if. This is to make sure that the compiler will not compile one header file multiple times. And when the compiler does that, you may have unexpected behavior. Naming conventions. So for function names, the function name should be a concatenated string of words with the first letter of all words capitalized, except for the first one. And the name should describe everything that the routine does. And for a procedure name, so use a strong verb followed by an object such as print report and calculate monthly revenues. And for function name, so use a description of the return value. For example, say next customer ID, which will return the ID of the next customer. And print ready function will return yes or no. Yes, the printer is ready. No, the printer is not ready. And current pin color will return the color of the current pin. And here you should avoid meaningless verbs. What do we mean that some verbs are meaningless? That's because some verbs are too general. They are too elastic, and they can be stretched to mean anything. For example, such as the verb handle, perform, process, deal with. They really can mean anything you want them to mean. The problem of having such function name is that the reader of your function will not know what does this mean. What do you really want to do in that function, unless they read your implementation, and that should be avoided. And here only one exception should be the verb handle that's used to handle event. So you should avoid the function names such as handle output. You should, for example, and you can use format and print output. That's much better because that explains in a much more clear way of what that function does. And many times a verb is vague because the operations that performed by that routine or the function are vague. And when the routine suffers from a weakness of purpose, and often the weak name is a symptom. And when that's the case, what you should do is to restructure your routines. Basically, you can decompose your routine. If it does too many things, then each new routine will have a much stronger purpose, and you have a much clearer name to accurately describe it. And the properties of a class should be accessible through some get functions, set functions, and also there's functions is something. For example, you check whether your stack is full or not, is full, or is empty or not, is empty. That will return a Boolean value. Class names. So the name of a class should be a concatenated string of words with the first letter of all words capitalized, such as employee, manager, focus event, device context, customer, and so on. Variable names. So variable names are concatenated strings of words with the first letter of all words capitalized, except the first one. And the name should clearly represent the content of the variable. For example, window handle, that means the handle of a window, and event consumed, index, and so on. And all the variables that are a member of a class, basically data members, should have a m_ prefix. And in some coding standards, they don't have this m, they just put this underscore. Well, I would prefer to put m here, such as m_window handle and m_event consumed, m_index. The reason that we want to use this m prefix is that in a member function, the member function can access not only the local variables defined in that function, but also can access the data members defined in a class. And many times you want to distinguish these two types of variables. So that's why we use this m_ to distinguish that for the data members of a class. And for constants, well, constants you should follow the standard in C++. You basically use all capitalized and use underscore to separate the words, such as max array length and size property name and so on. Okay, so source documentation. So the inline comments should be made with this / comment style and should be indented at the same level as the code they describe. And the module headers are blocks of headers placed at the top of every file. And the block comments should contain enough information for the readers to understand your file. For example, this you can include the file name and abstract. For example, this says a general description of the module's role in the overall software architecture, and what services that this file provides, and what interfaces that this file interacts with other components of the system. Documents, you can add some reference to some applicable design documents somewhere, and authors, you put your names here, and the creation date, and also you can have revision date and so on. So note that for the block comments, on the left we have all these stars to indicate this is the left boundary, and on the top we have this line of stars, and on the bottom we have this line of stars. And sometimes you can see people they put a straight line here for the stars, and we purposely leave that out because that's very difficult to maintain, because if you add a word here, then these will out of shape and you have to manually align them. That's just a waste of time. So you should also commenting the date declarations. So the comment for variable declaration should describe the aspects that the variable that the name that cannot describe. Basically, add the information that that will complement for people to basically complement to the name of the variable that the people can easily see. And you should comment the units of numerical data. If a number represents, say, length, then you need to indicate whether it is expressed in inches, feet, meters, or kilometers. And if it's time, then you should indicate whether it is expressed in terms of seconds since January 1st, 1980s, or in terms of milliseconds since the start of the program, and so on. You should explain what does that mean and what's the unit. And you should comment the range of allowable numerical values. For example, if a variable has an expected range of values, then document the expected range. And should document the flags for at the bit level. So if a variance a variable is used as a bit field, then you should document the meaning of each bit. You should also document global data if you have global data. And you should indicate the purpose of the data and also why it needs to be global. You should comment the control structures such as if, else, case, and those while loops and for loops and so on. So basically you should, before this control structure, you put a block of comments to explain what does this block structure will do. And for those if statement or case statement, and for each branch, you should give a reason that why for this branch, for this case, we should do the following way. And for loops, you can add some comments about the purpose of the loop, and also when the loop will terminate. You should always comment routines, so describe each routine in 1 or 2 sentences at the top of each routine. Well, if you cannot describe something in the routine in a short sentence 1 or 2, it might be a sign that the routine include too many things, and so that's why you have to describe in many sentences. And if that's the case, you may want to decompose the routine into multiple subroutines so that each of them will have a much clearer purpose. And don't try to explain everything in the block header. Instead, you add comments in the code close to the code that you are commenting. And in the block header, you should try to indicate which variable are input and output, and which variables are output, and also in addition, and so the return of the function should also be described. And you should always document the variables when they are declared. So basically you just add the comments next to the variable. And also, very importantly, you should document interface assumptions. Basically, for example, you take a variable as the parameter, and if you assume this variable is initialized or should be within some range, then you need to document such assumptions. Then anybody who call this function will make sure that they satisfy your requirement. And also you should comment on routine limitations. If the routine provides a numerical result, say document the accuracy of the result, for example. And if the computation are undefined under certain conditions, then you should document such conditions. And also you should try to document routine's global effect. And if the routine modifies some global data, then you exactly want to describe what this routine will do to the global data. And also if you use some algorithms in your implementation, then you should document the source of the algorithm. Maybe it is written in some book or in some papers. You want to document the source of the algorithm, basically give the reference, the name of the book, or the title of the paper. And if you develop the algorithm by yourself, then you want to indicate where the readers can find detailed description of your algorithm, maybe in some internal document of in your company. Okay, so the use of parameterized macros should be minimized. Basically, in the past, parameterized macros, people often use them because they are faster, because the pre-processing stage will pre-process these macros, and when the compiler compiles such code, unlike functions, they are going to have dealing with the stacks and so on. So for parameterized macros, they automatically generate the code basically in the pre-processing stage. But nowadays computers are already much faster, so you really don't need to optimize your performance by using such macros, because for macros, the compiler do not generate proper symbols and they are very difficult to debug. So don't use macros, parameterized macros. So constant macros are better than literal values. For example, instead of just using literal value 100 in your program, if you use macro buffer size and make it equal to 100 and use buffer size macro in your program, then it is much easier to read. Alright, and so constant variables are better than constant macros. So because constant variables, they have types and they are visible for debuggers, so make your program easier to debug. And similarly, so enumerated types are better than literal values. Error handling. So a failure should never leave a class in an undefined state. So basically, if when you write, for example, when you write a file class, when you need to open a file and that opening may fail because, for example, say the file doesn't exist, and you should have the code to deal with such an error. And an error should be detected and handled. It affects the execution of the rest of the routine. For example, if you try to open a file and the rest of the code will depend on whether you can open this file or not, and so if it fails, then you definitely need to deal with it. But sometimes for some error, for example, say you're releasing a resource, and if that fails, then you can ignore. And if error is detected in a routine, so you need to try to notify your caller. And so if an error has a potential to affect your, if an error has the potential to affect your caller, this is very important that the caller is notified. For example, the open method of file should return error conditions, and even if the class stays in a valid state, and other calls to the class will be notified properly. So, and the caller might be interested in doing some error handling on their own. And don't forget that error handling code is also code, so it can be defective. They can have bugs. So it's very important that you should write some test cases that will test such errors. Class invariance. So class invariance is a statement about some constraint on some objects that belong to the class. And the class invariant means a condition that always holds true for the class no matter what state it's in. So, for example, say the size of a stack. For example, the size of the stack should be never less than 0, right? This could be an invariant of the stack class. And even every class should supply a function to perform a sanity checking on the class that will verify, if the class invariant holds. For example, the environment for Q class might contain a clause that requires the current size of the queue is between 0 and the maximum size of the queue. Defensive programming. So basically means that for non-trivial routines in your class, you should have the checking before they perform some actions. For example, you may want to do sanity checking before you take some actions, and sanity checking means the routine should call the sanity check method to verify that the class invariant still holds. And parameter checking means within a routine should verify that all the parameters passed to the routine are valid in their type, value, and range. Because an invalid parameter may disrupt the behavior of the routine, and you want to catch them once you receive those parameters. assert. So those assertions are used, the assert statements are used to check, to perform this kind of checking, this sanity checking. So to call the assert, you should include this assert.h. And here you should not use assertion to check error codes of a function. And if a function fails, you should handle the error with a real error handling code, not assertions. You should use an assertion to complain to the compiler when you in the debugging purposes, in the debugging process. So you should use assertion to guard your code that should never logically be executed when you release the code to the customer. So, for example, if you open some file and that file cannot open, those you should not use assert, because assert will not be in the release version, in the released version to the customer. And when assertion fails, so your program will terminate and print out, so it will say assertion fails, and include the expression. Basically, assertion always include this expression and file name, the file name and line number. So that's for you to check which assertion goes wrong. So remember, those assertion code, they should not be included in the release code to the customer. So validation test. So sometimes you want to build some tests into your system instead of you just perform some testing on top of your program. And for example, if you know, if you may have existing algorithm, existing function that's very simple but it's very slow, and you design a new function which is very complex but it's very, very fast, it's very much optimized. In that case, you may want to implement both functions, both algorithms in your program, and then when you call it, you call the fast one, the optimized one, but you may not, you don't know whether this is correct or not in the debugging process. What you can do is that you can also call the slow one, because simple and you know that's correct, and you can use assertion code. You can use assertion code to check whether they are equal or not, and this will not affect the performance of your program, because those assertion code will not be in the released code. So then you call this function will, so basically this slow function will not be called in the released code. And to avoid such assertions to be included in the release code, what you should do is you should use define ndebug, not debugging, so basically ndebug before the include assertion.h. If you don't have this, those assertion code will be in the released code. Let's take a look at the use of assertion. So again, you need to use this include assert.h, and you can, for example, here we use assert, say if s is not empty, this s is a stack, and if it is not empty, then I pop something out. You can do that, and here, and if you just want to test what will be the output of when the assertion fails, let's compile this. This is just for testing what 2 not equal to 3, this assertion will definitely fail. You can see that when it fails, it says assertion fails. Sorry, the font is very, very small. it says assertion fails, the condition that fails, and the file is this main.cpp and line 77. And if for all these assertion codes, if you do not want to include them in the release code, so here what you should do, you should use this n means not, then not debug. So n debug. You do compiling and you run. So you see, although this assertion fails, although this assertion will fail, but when you include this not debug, then the compiler will not generate code for such assertions. All these assertions, the compiler does not generate code for that. And this is the example that suppose you have two functions. One is this is a slow one, and you know it's correct, and this is suppose it's a fast one, which is you just implement it, and maybe incorrect. In that case, you can call this fast one, and in the assertion code, you call the slow one, and you compare with the result with the return of the fast one. And here, of course, you don't want to put this calling of this fast one also in the assertion, because once you define this in the in the released code, this assertion will not generate code for that. The compiler will all these assertions will be omitted by the compiler.